Welcome to NSMO, the National Science and Mathematics Olympiad. In this lesson, we will study another important periodic property known as electron affinity. Electron affinity helps us understand how willing an atom is to gain an electron and form a negative ion, also called an ion. Definition of electron affinity. Electron affinity is defined as the amount of energy released or absorbed when an atom in the gaseous state gains an electron. If energy is released when an atom gains an electron, the electron affinity value is said to be negative. If energy must be absorbed for an atom to gain electron, the electron affinity value is positive. In general, the more negative the electron affinity, the greater the tendency of the atom to gain an electron and form a stable negative ion. A more negative value indicates that the process is exergonic, meaning it releases energy. Meaning of electron affinity values. Electron affinity values help us compare how different elements behave. Elements with highly negative electron affinity strongly attract electrons. Elements with less negative or positive electron affinity do not easily gain electrons. Electron affinity is therefore closely related to a chemical reactivity, especially for nonmetals. Factors affecting electron affinity. Several factors influence the electron affinity of an element. The first one, effective nuclear charge. The effective nuclear charge is the net positive charge felt by an electron after accounting for shielding by inner electrons. As effective nuclear charge increases, the nucleus attracts the incoming electron more strongly. Electron affinity becomes more negative. Therefore, elements with a higher effective nuclear charge generally have more negative electron affinity value. The second factor is atomic size. Atomic size also plays an important role. When atomic size is small, the incoming electron is closer to the nucleus. The force of attraction is stronger. Electron affinity becomes more negative. When atomic size is larger, incoming electron is farther from the nucleus, attraction is weaker, electron affinity becomes less negative. So, smaller atoms usually have higher or more negative electron affinity. The third factor affecting electron affinity is the electron configuration. The electron configuration of an atom strongly affects its electron affinity. First, tendency to be full. Atoms that need only one electron to achieve a full outer shell, such as halogens, have highly negative electron affinity value. Gaining one electron makes them very stable. Second one, tendency to be half full. Atoms with half-filled subshells, such as nitrogen, are relatively stable. Adding an electron disturbs this stability and often requires energy, so their electron value are positive or less negative. Third time, filled shells. Noble gases have completely filled outer shells and are already very stable. Adding an electron requires a large amount of energy, so noble gas have positive electron affinity value, meaning the process is energy absorbing. Strength of electron affinity. Now let us examine how electron affinity changes in the periodic table. Across a period from left to right, as we move from left to right across a period, electron affinity generally becomes more negative. This is because effective nuclear charge increases, atomic size decreases, the nucleus attracts the incoming electron more strongly. As a result, atoms on the right side of periodic table, especially halogens, have very negative electron affinity value. Down a group, top to bottom. As we move from top to bottom, down a group, electron affinity becomes less negative. This occurs because atomic size increases, the number of energy level increases, the incoming electron is farther from the nucleus. These factors reduce the attraction between the nucleus and the added electron. Comparison with other periodic properties. Electron affinity is important because it helps us predict whether an element will form a negative ion, understand a nonmetal reactivity, explains why halogens readily gain electrons, analyze chemical bonding behavior. Electron affinity is closely related to other periodic properties. It increases across a period similar to electronegativity and ionization energy. It decreases down a group opposite to atomic radius. Together, these properties help explain trends in reactivity and bond forming. Electron affinity influences an element's physical properties and bonding behavior. Elements with high electron affinity nonmetals tend to gain electrons, forming negative ion or covalent bonds. Because they lack free electrons, they are poor conductors of electricity and heat. These elements often form simple molecules with weak intermolecular forces, giving them low melting and boiling points. So they commonly exist as gases or liquids such as oxygen and chlorine. When a high electron affinity nonmetal reacts with a metal of low ionization energy, strong ionic bonds form, producing ionic compounds with high melting point and boiling points that are usually solid, such as sodium chloride. Electron affinity is the energy change that occurs when an atom gains an electron in the gas state. More negative electron affinity value indicate a stronger tendency to gain electrons. Electron affinity is affected by effective nuclear charge, atomic size, and electron configuration. Across a period, electron affinity becomes more negative, while down a group, it becomes less negative. Halogens have the most negative electron affinity value, while noble gases have positive value. Thank you, and with my best wishes for success at NSMO.